In section 12.2.2, we're going to be looking at proving trigonometric identities and answering the question, how can I prove it? By the end of this lesson, you will be able to write algebraic proofs for trigonometric identities. Question 90 says, Thomas Trigg has decided to open a company called Identity Island. However, to do this, he needs some help and has sent your team the following memo. Dear study team, my goal for Identity Island is to be able to offer a wide selection of trigonometric identities to interested customers. I found a list of identities on the internet, but I know that lots of information on the internet is false. I cannot afford to be embarrassed in front of my potential customers by offering identities that are not true. I need your help. I need a solid algebraic proof on file for each identity that we offer. Please submit a report by the end of the day that demonstrates each of the identities algebraically. I have the utmost faith in your team's abilities. Thank you for your time. Sincerely, Thomas Trigg, your CEO of Identity Island. We're going to do a couple of these together, and then you're going to work on a few in your teams of 4. So for the first one, we're going to take 1 over secant squared x plus 1 over cosecant squared x, and it is equal to 1, and the directions basically want us to prove that it's true. So you're going to look for the side of the equation that is that needs simplifying in this case. So on the left, we're going to take the secant squared and rewrite it as 1 over cosine x squared. And on the 1 over cosecant squared, we're going to rewrite as 1 over the sine of x squared. When we take the reciprocal of the reciprocal, we get cosine of x squared plus the sine of x squared, which is one of our identities, and is equal to 1. The right side of the equation is already equal to 1, so this one proves to always be true. For number 2, we're going to take the secant squared of x and rewrite it as 1 over the cosine of x squared. We're going to take the cosecant squared of x and rewrite it as 1 over the sine of x squared. We're going to take the tangent squared of x and rewrite it as sine of x squared over cosine of x squared. And we're going to take the cotangent squared of x and rewrite it as cosine squared over the sine of x squared. Now we're going to move everything to the left-hand side. Just do the opposite of this, and the opposite of this becomes that one, and the opposite of that becomes that one. So I grouped them together because these two were both cosine, and these two are both sine, so we can rewrite them with a common denominator. So these two we get rewritten with a common denominator of cosine of x squared with 1 minus sine x squared in the numerator, and these two get rewritten with a denominator of sine x squared with 1 minus the cosine of x squared in the numerator, and I pulled out the negative sign, and then the identity of this one is cosine x squared, the identity of this one is sine of x squared, and so this expression simplifies to 1, and this expression simplifies to 1, but there's a negative in front of it. So 1 plus negative 1 is 0. So we end up with 0 equals 0, and that proves that it is always true. Go ahead and flip over to the top of page 20. All right, at the top of page 20 is question 90, where it says you're going to work with your team to prove each identity below. I'm going to do 3 and 4 for you, and then in your teams you're going to do 5 and 6. All right, so for number 3, we're just going to rewrite we're going to take the 1 minus the sine of x and multiply it times the 1 plus the sine of x, and I actually use FOIL, which these would be opposites. The outside and the inside would be opposites. 1 times 1 is 1, and sine of x times sine of x would be sine x squared. And then the right side of the equation, I'm going to simplify the 1 over the 1 plus the tangent squared. I'm going to rewrite the tangent squared x as sine of x squared over cosine of x squared. In order to simplify this denominator, I need to get a common denominator. So sine of x squared is right here, but 1 I'm going to rewrite as cosine of x squared over cosine of x squared so that I can simplify it. And then this is the identity of 1. So we have 1 over the 1 over cosine of x squared, which is cosine of x squared. So cosine of x squared equals cosine of x squared, and that proves that the identity is true. Number 4, we're going to take the cotangent of x and rewrite it as cosine of x over sine of x. We're going to rewrite tangent of x as sine of x over cosine of x. And we're going to leave the right-hand side alone for right now. Now we're going to take these two and rewrite them with a common denominator of sine of x cosine of x, which means I need to multiply this one by the cosine of x. That's where the squared comes from. And I need to multiply this one by the sine of x, which is where the sine of x squared comes from. And then the numerator is our identity, 1 over the sine of x times the cosine of x. You can either separate them, or you can see even in this step that 1 over the sine of x is going to be the cosecant of x, and 1 over the cosine of x is the secant of x. So they are equal to each other. You are going to try 5 and 6 in your groups of 4, and then you're done with this section.